Hello, welcome to Lecture 1.1, your first lecture for this course. My name is David Haywood and I will be your instructor for the course. So I'm excited to dig in. Before we do, there are just a couple things that I wanted to say to make sure that everything goes as smoothly for you as possible. First of all, make sure that you are watching this lecture through Canvas and not through YouTube or something like that. So make sure that you're actually accessing the lecture through Canvas. The reason for that is because there will be embedded questions throughout the lecture that you will need to answer, and you'll receive a grade for that, right? So if you're watching it through YouTube, you won't get the grade you won't get credit for having watched the video. So you want to make sure that you're watching it through Canvas so that you get credit for watching the video and so that you're able to answer the questions as you go through the video. The second thing that I wanted to make sure that you did is that you have downloaded the notes or printed the notes. If you're using a tablet, then you'll want to download the notes so that you can write on them with your tablet. And if you don't have a tablet, then you'll want to print them so that you can write on the printed notes by hand. And make sure that you're taking notes as we go through this lecture, because I will be collecting your notes for each lecture that we cover. And so you'll need to make sure that you are taking notes on the actual prepared notes that I have for you. And let me just show you real quick where you can find those on Canvas. So it may look a little bit different on your end because this is an old course. This is an old course I taught this last summer. But generally speaking, I'll have a lecture, like a page or an assignment for each lecture that you can open up. And then inside of that lecture, you'll have a video that you can watch. And then you'll also have a set of notes that you can download. Now, you don't just want to open this up. You want to actually download it. And then you can open that up. And now you've got this set of notes. You can either print this or you can download it and write on it with your tablet. But you want to have these notes ready to go so that you can take notes as you go through this video. And with that, let's get started. So we are indeed going to be talking about just some introductory vocabulary in this first section. And just as a kind of upfront warning, most of the sections in this course are not going to be this way. So if you feel a little bit overwhelmed because I'm throwing a lot of terms at you, just know that it's not always going to be this way. I'm kind of gonna front load you with a bunch of terminology so that I'm sure that we're all kind of speaking the same language. So let's get right in, right? Statistics is the science of collecting, organizing, summarizing, and analyzing data. We'll talk about data in a second, but statistics is useful in any field of study that involves data, which is most fields of study these days. So I think that it's an exciting course. It's unlike any other math course you've likely had in the past, because statistics, unlike algebra or calculus, it was developed specifically to solve real world problems. So it has direct application, right? The entire field is an application. So anywhere where you're going to encounter data, statistics will be useful. We're going to have 3 units in this course that we cover. Actually, kind of 4 units. The 4th unit will be kind of projects in it, but there will be a few kind of new concepts in the 4th unit as well. But anyway, in the first unit, so all of the chapter 1 material, all of the unit 1 material, our goals are going to be to first of all describe and compare data sets by identifying their shape, center, and spread, as well as any unusual values, which we usually call outliers. And then number 2, what we want to be able to do is describe and compare individuals within a data set and compare individuals maybe in different data sets, right? So those are going to be our main goals in this chapter. And in this first section of the first unit or first chapter, we're just going to go through some vocabulary. So let's talk a little bit more about about statistics and about data. The entire group of individuals that we want to study are called the population. An individual is a person or object that's a member of the population being studied, and then a sample is a group of some of the individuals in the population that's being studied. So, in other words, the sample is kind of a subset of the population. We are usually interested in knowing something about the entire population, right? We want to be able to answer questions like, what's the average height of 3-year-old boys, right? Or what's the proportion of US high school students that have an Instagram account? But usually it's going to be impossible to get information about every individual in the population. If not impossible, it's at least very difficult, time-consuming, expensive. And so what we'll do instead is we'll just collect information about some of the individuals in the population, right? And we call that a sample. And then we use that information to extrapolate about the population at large. The characteristics of the individuals within the population are called variables, and the list of values that the variable assumes is called data, right? So that's what data is. In other words, the variables are the categories of information, right? They're the categories of information, and the data are the actual observations themselves, right? So, for example, hair color would be a variable, but the observations, right, when you go through and you look at somebody and you determine what their hair color, black, brown, whatever, those are data, right? When you start to actually collect the hair colors of the individuals, now you've got data, right? So hair color is the variable, but the observations are the data. So just to give a quick example of this, a researcher is interested in the height of the adults who live in Visalia, California. So she collects information about 5 adults living in Visalia and finds that their heights are 61, 67, 74, 63, and 70 inches. And then we're asked a few questions about this. What I'd like you to do is pause the video and see if you can answer those questions on your own. And then once you have your answers, you can unpause the video and see what I'm going to say. And this goes for every example we go through, right? I always want you to kind of pause the video, try it out on your own first. But I'm going to go ahead and give you my answers here. So what's the population in question in part A? Well, she was interested in the height of adults who live in Visalia. So that would be the population. Or sorry, not heights. That's the variable, right? The population in question is just the adults in Visalia. Adults in Visalia. Okay. Part B, what is the size of the sample? Well, it looks like she collected information about 5 of the adults in Visalia. The letter that we use to represent sample size is n. So we'll say n equals 5. Okay, what's the variable in question? Well, I already answered this, right? But she was interested in the heights of those adults, right? So height is the variable in question. And then what are the data? Well, it would be the actual observations, right? She observed those values when she started measuring people's heights, right? So the data are 61, 67, and so forth. Okay. When you have some data to work with, then usually what we want to do is we want to give some kind of summary of that data. If you have an entire population's worth of data, we sometimes call this a census, okay? But if you have an entire population's worth of data, then the summary that you get from that is going to be called a parameter, right? Whereas if you only have a sample, then the summary is going to be called a statistic. So you have population parameters and sample statistics. Usually our goal is to try to estimate what a population parameter would be using a sample statistic, right? We would use a sample statistic to estimate a population parameter. Those letters go together, right? PP and SS, right? So it's a population parameter, a sample statistic. It never makes sense to talk about a population statistic or a sample parameter. That's nonsense, right? So for example, the average height of all the adults living in Visalia is a parameter, while the average height of the 5 individuals in the sample is a statistic. And again, because it's usually impossible, or if not, at the very least, it's impractical to get information about the entire population, usually what we're going to be doing is relying on our sample statistics to try to get an estimate for our population parameters. So this next example asks us to determine whether the underlined values represent a statistic or a parameter. And in order to do this, what you need to do is ask yourself, well, is this a summary of an entire population, or is it a summary of just a sample? So I'll let you pause the video and answer these questions. And then when you're ready, I'll give you mine. I'll give you my answers. By the way, you might hear my dog snoring in the background. Okay, so here are my answers. Part A, we have this $123.7 million. That's the average. It's an average of 35 movies. So I'm going to say that that's a statistic because I know that there have been more than 35 movies made, right, in the history of cinema. So this must be a sample, right? This 35, it must be a sample of just some of the movies that have been made, which means the underlined value here is a statistic. It's a sample statistic. Okay. Part B, College of the Sequoias, 13,703 students are male, 16,311 are female. Those are definitely parameters because COS is going to keep close track of all of its students. So I think this represents all of the students at the school. It's not just a sample of some of the students, it's all of them. So these must be population parameters. Okay. Part C, according to a survey, 42% of registered voters are in favor of the death penalty. That one's maybe a little bit trickier, but here's the thing. I am a registered voter in the United States of America, and nobody called me to ask me my opinion about the death penalty, right? So this couldn't possibly be coming, this underlined value here couldn't possibly be coming from an entire population since nobody asked me, and I'm part of the population, right? So it's not a parameter. It's got to be a statistic. This must have been based on a sample, right? So this is a sample statistic. Okay, and then part D. In Visalia, California, there are 132 traffic signals with walk buttons. I don't know if this is true, by the way. You got to take all this stuff in these lectures with a little grain of salt. But anyway, we'll say there are 132 traffic signals with walk buttons. It was found that 5% of those buttons do not work. Okay. So this 5%, right, it's referring to the percentage of these 132 traffic signals that don't work. And that's all of the traffic signals with walk buttons in Visalia, California. That's what the first sentence says. So I think this 5% right here is a numerical summary of an entire population of traffic signals, right? So it's a population parameter. Okay. So next, let's talk about variables a little bit more, because when you're collecting data, it's because there's usually some kind of variable that you're interested in studying about the population. Those variables can come in different types, right? So the two broad categories of variables are numerical and categorical variables. Numerical variables are more properly called quantitative variables, but I call them numerical because I think it's just an easier term to kind of relate to. A numerical variable is basically just a number, right? It's a variable that provides a mathematically meaningful numerical measure of individuals. The other kind of variable is called a categorical variable. Categorical variables are sometimes called qualitative variables because instead of providing a numerical measure of individuals, it's just going to be a variable that is the quality of some individual, right? So we call those ones categorical or qualitative variables. So I'll use the terms numerical and categorical most of the time, but occasionally I might slip up and say quantitative or qualitative, right? But those things are synonymous. Now, within those broad categories of numerical and categorical, there are subcategories, right? A numerical variable could be discrete or it could be continuous. A discrete variable, you get the values for a discrete variable by counting something. And there's one way to tell that a variable is discrete is that there's usually not going to be units of measurement because you're not measuring, you're just counting, right? So for example, the number of books you own would be a discrete variable, or the number of people in a household would be a discrete variable because you would count the number of books, right? You would count the number of people. A continuous variable, on the other hand, would result from, or you would get the values for the variable by measuring something. And so those are going to have units of measurement. This would be things like height, weight, speed. So, for example, measuring height, you don't get someone's height by counting. You measure them, right? You measure, and then there are going to be units of measurement involved there. Maybe you measure in inches, maybe you measure in centimeters, but there's going to be some kind of unit of measurement. Same thing with weight. You could measure in pounds, you could measure in kilograms, right? But there's going to be some kind of unit of measurement, and you get somebody's weight by measuring, not by counting. Same thing with the speed that somebody is traveling at, right? Kilometers per hour or miles per hour or something like that, feet per second, whatever. But there's going to be some unit of measurement, and it's going to be measured, right? Not counted. So those are the types of numerical variables, sort of the subtypes of numerical variables. Categorical variables also have different subtypes. You could have a nominal variable or an ordinal variable. Nominal variables have no naturally implied order to them. So this would be something like a person's religion or their favorite sport, right? There's no like implied order there. I also put phone number here, which is kind of an interesting one because you might think, well, wait a second, a phone number is a number, so shouldn't that be a numerical variable? But the answer is no, because remember, a numerical variable they're numbers, yes, but they have to be mathematically meaningful, right? And a phone number is not mathematically meaningful. It's just a random string of digits that was assigned to you when you got your phone, right? And there's no order. It's not like if somebody has a phone number that has a larger numerical value that's somehow meaningful. When it comes to phone numbers, it just doesn't matter at all, right? So that's a nominal variable. Ordinal variables, on the other hand, do have an implied order to them. So something like level of education. First of all, yes, that would be a categorical variable because maybe you have like your level of education could be a high school graduate or a college graduate or somebody with a PhD or whatever. Right, so there are different levels of education. It's not a numerical variable, so it's categorical, but there is an implied order to it, right? Having a high school diploma is less education than having a bachelor's degree, which in turn is less education than having a PhD, right? Same thing with karate belt rank or Olympic medal earned. These are categorical variables, but there's an implied order or ranking to them. So here's kind of a visual to summarize that. You have data, and that data can either be categorical or it can be numerical. If it's categorical, then it could be nominal or ordinal. If it's numerical, then it could be discrete or continuous. It never makes sense to talk about a qualitative variable that is discrete, right? That doesn't make any sense at all. And similarly, it doesn't make sense to talk about a quantitative variable that's nominal, right? That doesn't make sense. The subcategory of nominal belongs to the category of qualitative or categorical. Okay. When talking about how to classify different variables, it's easy to get sort of lost in the details. The whole reason that we care about categorizing variables is that it helps us with the analysis that we're going to perform later. So if at any point it stops being helpful, then we don't need to worry about it so much. So the boundaries between different variable types can sometimes be a little bit fuzzy, and you really just don't need to stress out about that too much. Generally speaking, we can categorize variables into different categories. That helps us with the analysis we're going to perform later on. So in the next example, I'd like to do that. I'd like to just categorize these different variables based on whether they are numerical or categorical, and then if they're categorical, whether they're nominal or ordinal, and if they're numerical, whether they're discrete or continuous. So once again, I'll let you pause the video and answer these questions. I'm going to go ahead and give you my solutions now. So part A asks for citizenship status. Clearly that's a categorical variable. So it's categorical. I'm just going to abbreviate. And then whether it's nominal or ordinal, again, the boundaries are somewhat fuzzy. I could see somebody arguing that this would be an ordinal variable if maybe they think being a full citizen is better than just having a work visa or something like that. But I would argue that it's not. There's no like naturally implied order here. So I would just say it's nominal. Maybe some people don't want to be permanent residents, right? And so you can't say that being a full citizen is better than having a work visa. Maybe the person only wants to have a work visa. So I would just say that it's a nominal variable. Part B, number of children in a household. Well, clearly that's going to be numerical. And you don't measure the number of children in a household. You count the number of children in a household. So that means it's discrete, right? So this is numerical. And it's discrete. Okay. Temperature on a thermometer. Well, that's also going to be a number, but temperature is something you measure, and it has units of measurement associated with it. So this is going to be numerical, but continuous. Okay. And by the way, as I'm going through my solutions, if you're realizing that, oh, wait, my thinking was wrong about parts A, B, and C, then instead of just watching me give the rest of the solutions, maybe pause it again and see if you can redo the rest of them now that maybe you have a better understanding. But I'm going to keep going. Okay, part D, finishing place in a race. That might seem like a numerical thing because, first, second, third. But notice that first, second, third, they're not really numbers, they're categories, right? It's not 1, 2, 3, it's first, second, third. So I would say that that's categorical, and I would say that it's ordinal because there's an implied order, right? First finished first, and second finished second, right? So this is a categorical variable. That's ordinal. Okay, I'll try to go through the rest of these a little quicker. Marital status. I would say categorical, nominal. Okay, no implied ranking there. Number of students in an algebra class, that's numerical. And it's discrete. Gender, I would say that's categorical. And nominal. Age, I would say, is numerical. But now here we might have a little argument about whether it's discrete or continuous, because you might think, well, you count the number of years that you've lived, and that's your age. On the other hand, you could argue, well, you measure the amount of time that has elapsed since you were born. So, so depending on how you want to argue that, I would personally say that it's continuous. I think actually age is a measure of time, right? It's how long you've lived. So it's a measurement. Okay, MPAA movie rating, G, PG, PG-13, etc. I would say that this is categorical and ordinal. I think there's an implied ranking there, right? G is sort of the most innocent of the rankings, and then all the way up through R, NC-17, whatever. Those are more egregious. So there's a ranking. And then finally, social security number. Now, this is a number, of course, but it's not a mathematically meaningful number. So I would call it a categorical variable. I would also say there's no implied order to it. It's just a random string of digits that is assigned to you. So So I would say that it's nominal. Okay. When you go to collect your data, broadly speaking, there are going to be two ways that you can obtain it. First way is to do an observational study, and the other way is to do a designed experiment. To understand the difference between those things, it's helpful to talk about explanatory and response variables. These are not different variable types, they're just different assignments that we give to the variables within a study. Let me say what I mean. So the variable that causes something else to happen is called the explanatory variable. You may have heard it referred to as the independent variable in the past. And then the variable that the explanatory variable affects is called the response variable. You may have heard that referred to as the dependent variable in the past. So in other words, the explanatory variable is the cause, and the response variable is the effect. These variables, the explanatory variable, it could be categorical, it could be numerical, same thing with the response, right? So they could fall into any kind of categories in terms of whether they're numerical, categorical, discrete, whatever, right? But the point is that an explanatory variable is what we think of as the cause in our study, and the response variable is what we think of as the effect. So now, getting to observational studies and design experiments, in an observational study, the researcher measures the value of the response variable without attempting to influence the explanatory variable, right? They just observe. Whereas in a designed experiment, the researcher directly manipulates the explanatory variable in order to see if changing that explanatory variable causes a change in the response. Okay? Usually when they're doing this, they try to hold all other variables constant so that they can really make sure that it's the explanatory variable that's causing, the response variable to change. So let's look at a few examples of this. It says, are the following studies observational studies or designed experiments? What are the response and explanatory variables? As always, right, you can pause and kind of try these out for yourself. Part A says, a study conducted at Virginia Polytechnic Institute divided female undergraduate students into two groups and had the students perform as many sit-ups as possible in 90 seconds. The first group was told only to do your best, while the second group was told to try to increase the actual number of sit-ups they did each day by 10%. After 4 days, the subjects in the group that were given the vague instructions averaged 43 sit-ups, while the group that was given more specific instructions averaged 56 sit-ups in the last day's session. Okay, so we're not being asked to do any math here or anything like that. We're just being asked, is what was just described to us an observational study or a designed experiment? And to answer that question, we have to determine whether the researchers were intentionally manipulating the explanatory variable. If they were, then it's a designed experiment. If they weren't, then it's just an observational study. So with that in mind, maybe it would be worthwhile to read through the text again and see if we can determine what the response and explanatory variables are. I think the response variable here is pretty clear. It's the number of sit-ups that they're able to do the last day, right? That's the response variable. The explanatory variable would be what kind of instructions they were given, right? Because the first group was told just do your best. The second group was told to increase by 10% each day, right? So I would say the explanatory variable is explanatory variable is instructions. Instructions given. And the response variable is number of sit-ups. Whoops. Okay. Now, here I think the researchers were actively manipulating that explanatory variable. They had to in order to give the instructions, right? They were directly involved in the manipulation of that variable for each group. And so I would call this a designed experiment. Okay, part B. It says hypertension can lead to cardiovascular problems. A group of 1,006 adolescents with pre-hypertension were tracked over several years to assess which health factors led to hypertension. So we have this group of adolescents with pre-hypertension, and we want to track them to see what health factors lead to full-blown hypertension. So in this case, I'm not even sure that we know what the explanatory variable is. It kind of seems like the point of the study is to determine what the explanatory variables might be. So as far as the explanatory variable is concerned, I would say question mark. Right? This is the point of the study, right? To try to figure out what the explanatory variables are. The response variable is whether or not they develop hypertension, right? So I would say developing hypertension. Now, since the researchers don't even know what the explanatory variables are, clearly they're not actively manipulating them, and that makes this an observational study, right? They're just going to observe. Observational study. They're just going to observe these adolescents, right, to see what happens. Okay, one more. Researchers wanted to assess the long-term psychological effects on children evacuated during World War II. They obtained a sample of 169 former evacuees and a control group of 43 people who were children during the war but were not evacuated. The subjects' mental states were evaluated using questionnaires. It was determined that the psychological well-being of the individuals was adversely affected by evacuation. So the explanatory variable here is whether or not the children were evacuated, right? I'll just say evacuation. The response variable would be their psychological well-being, right? And now the question is, were the researchers directly involved in manipulating the explanatory variable? And I would say no, right? It's not like they went back in time and evacuated some children from war zones in World War II and left other children behind in the war zone. Like, this is not what they did. They just went and administered a questionnaire to people who they knew had been evacuated during the war, right? So they weren't actively involved in manipulating that explanatory variable. And that makes this another observational study. Okay. Couple more topics, and we're almost done. When you are trying to collect your data, right, you have to get a sample of individuals that you're going to count or measure or whatever the case may be, right? And so when you're doing that, when you're trying to get your sample, you need to employ some kind of random process in order to make sure that you're getting a representative sample, right? A sample that's truly representative of the population that you're trying to capture. So random sampling is the process of using chance to select individuals from a population to be included in the sample. The idea behind random sampling is that everyone in the population should have an equal likelihood of being selected to be in the sample, right? If there's any other kind of sampling technique being employed, then it is not a random sampling technique. Now, there are various techniques that we can employ to obtain random samples, but at the end of the day, what's important is that the researchers must not rely on their own personal judgment to decide which individuals are part of their sample. And as I said a second ago, the sampling technique must allow an equal likelihood that any individual will end up in the sample. Samples that are not random are called convenient samples, and convenient samples should be avoided, right? It's important that we try to get a random sample rather than brute force trying to get a sample that's representative of the population. In other words, you might break up the population by race or something and say, well, since 13% of the population are this race and 17% of the population are this other race and 24% are this other race, I need 13% of my sample to be this first race and 17% to this other and 24. It's like you could try to do that, but the thing is that there are always going to be characteristics of the individuals in your sample that you are not aware of, that you're not taking into account, right? There are going to be unperceived differences between individuals in your sample. And so if you try to brute force get a representative sample, you're always going to be missing out on those. And so randomness is really the best technique to help us avoid that, right? So I want to go through several examples here to determine which scenarios are random samples and which are convenient samples. So as always, go ahead and pause, give these a try. But I'm going to go ahead and give you my solutions. So part A, student wants to survey COS students, so he stands in the quad and occasionally asks a student who passes by to participate. The way he decides is by his gut feeling. Clearly a convenient sample, right? This is important because sometimes students will, they'll do a project at the end of the semester where they have to get a random sample. And sometimes they'll say, yeah, I'm going to go survey a bunch of people about this, that, or the other. And then when I ask them, okay, how are you going to determine that your sample is random? And they usually say, well, I'm just going to randomly go up to people. But the point is, if you're just randomly going up to people, there's still some kind of bias implicit in the people that you choose, right? You can't use your own personal judgment to just randomly go up to people. Subconsciously, you're probably looking at, this person and saying, oh, they look kind of scary, I'm not going to go up to them. Or, oh, they look really busy, I'm not going to try, right? And so then that's not a random sample. You're using your own personal judgment to get the sample. It's a convenient sample, right? So here's a way that you could get a random sample. Part B, a student wants to survey COS students, so he stands in the quad and asks every 10th student who passes by to participate. That's a random sample. And that might seem a little bit strange because you're like, wait, every 10th person, that's not random. That's very systematic. In fact, that's exactly what this kind of sampling technique is called. This is called a systematic sample. The reason that we consider it to be random is because you don't choose who the 10th person is, right? and so you're eliminating your own personal bias. And so it's a random sample. Okay. Part C, a researcher wants to know if men and women have different preferences about pets. So she designs a survey and posts it on Instagram. Well, that's going to be a convenient sample. The reason it's a convenient sample is because not everyone in the population is going to be equally likely to see that survey, right? What about people who don't have Instagram accounts? Or what about people who do have Instagram accounts but don't follow this particular researcher? So this researcher's data is going to be biased in favor of people who follow her on Instagram, right? So that's not a random sample. That's a convenient sample. Part D, a researcher wants to know if the men and women who follow her on Instagram have different preferences about pets. So she designs a survey and posts it on Instagram. Okay, now that's a random sample. Okay. You might think, but the researcher didn't do anything different. And you're absolutely right. The researcher didn't do anything different. She still just designed a survey and posted it on Instagram. The difference is the population that she was interested in studying. In part C, she wanted to know about all men and women, right? Whereas in part D, she only wanted to know about men and women who followed her on Instagram. And so for part D, it's totally appropriate for her to just post the survey on her Instagram account. Whereas in part C, that would not generate a random sample. It would not generate a sample that is representative of the population she's trying to study in part C. So what would she do? What could she do if she was trying to obtain a representative sample of the entire population of men and women, not just of men and women who follow her on Instagram? Well, she could do something like part E. It says a researcher wants to know if men and women have different preferences about pets. So she designs a survey and uses a computer program to generate 50 random home addresses, visits those addresses, and administers the survey to those present, right? That would be another random sample. Okay, a couple more. A professor in a large lecture needs a sample of 10 students to participate in discussion groups, so she uses her personal judgment to choose 10 students. Clearly, that's convenience. She's using her personal judgment. Okay. Part G, a professor in a large lecture needs a sample of 10 students to participate in a discussion group. So she prints a list of the names of the students in her class and draws the names of 10 students out of a box without looking into the box. That's a random sample. Okay. So that's random sampling. Generally speaking, obtaining something truly random is actually a very difficult thing to do, but it is worth our efforts, right? And it should also be said that you're never going to obtain a perfect sample. So no sample is going to be perfectly random, but the degree to which we can get a random sample, like the more random we can make it, the better. Okay. So finally, let's talk about our last set of terms here, placebos and blinding. So once you have your sample and you're collecting your data, if you're performing a designed experiment, we usually wish to have a control group to which an already existing treatment or perhaps no treatment at all is being applied. Now, if that control group is given no treatment whatsoever, then they know that they're the control group. And knowing that they're the control group could affect the responses that they give to different things. It could affect the way that they respond to different stimuli. And so what we like to do, if at all possible, is we like to try to trick the control group into thinking that they are receiving a treatment. So sometimes the control group is given a fake treatment that does nothing to them, but looks, tastes, and smells like the experimental treatment. And this is called a placebo. So you've probably heard that term before, but that's what a placebo is. The use of placebos is not always possible, but when it is, we like to try to use one. For example, if a doctor wants to test a particular heart medication, she might give one group the medication and the other group a sugar pill, right? And in this case, the sugar pill would be the placebo. And then finally, in conjunction with placebos, many experiments will use a technique called blinding to make sure that each group gets treated the same way. If you're giving one group a placebo, you do not want them to know that that's what they're receiving, because that would defeat the purpose of giving them the placebo in the first place, right? So we use blinding to make sure that the groups don't know what treatment they're receiving. In single blind experiments, the experimental subject does not know which treatment he or she is receiving. In double blind experiments, neither the experimental subject nor the researcher in contact with the experimental subject knows which treatment the experimental subject is receiving. And that might seem a little bit confusing, because you might say, well, wait a second. If it's a double-blind experiment, then nobody knows what's going on? Like, how do they keep track of anything? But the answer is, like, somebody is running the whole show kind of behind the scenes, and they know what's going on, right? But the researcher who is in direct contact with the experimental subject doesn't know whether they're giving the experimental subject a placebo or the real medication, right? And in that case, we've got a double-blind experiment. So that brings us to the end of this kind of long section of vocabulary. Here is just a summary of the terms that we've covered, and I would highly recommend making some flashcards and committing this terminology to memory. But that'll do it for our first section. You're troopers for hanging in there. I look forward to working with you throughout the semester, and I will check in with you in the next one.